Hey, welcome back to your favorite technical math class. We're going to take a look at points, lines, and angles. And so let's first start out with a point. It's just represented by a small dot, right? Has no length, width, thickness. A line, such as line AB, notice the arrow's going in both directions. Or you could say line BA, it really doesn't matter, has no thickness. A line segment now has a starting and a stopping point, right? So you notate it with that line segment AB or line segment BA. A ray, though, is directionally oriented. So if you're going from, let's say, B through C, you would say ray BC, right? Or line AB starts at A, goes through B. So there is a direction to that. Angles, we have an initial side. Well, first of all, we have this vertex right here, and then we have this initial side, and it rotates to the terminal side. Maybe this rotates 50 degrees, right? And so initial side's where you start, terminal side's where you end. Let's do another one. Maybe we can rotate this time maybe 120 degrees, right? Or, oops, we could go even more than that. Maybe we could go 300 degrees and so on, right? How do you name an angle? You can name it using the vertex, so that's angle B. You could name it with the points on the ray from the initial terminal side. So you can name it angle ABC. See how it goes from A through the vertex to C. Or you could name it angle CBA. Again, the vertex has got to be in the middle. See how you name it, angle CBA. But either way, B's got to be in the middle if you're going to do it that way. And finally, you could just use, if you call this angle 1 inside, you could just say angle 1 as well. So how are angles measured? It's the measurement from your initial side to your terminal side, however far that is, maybe 90 degrees. The degree term is 360. It takes 360 degrees to go all the way around, right? All the way around, one complete rotation. So 1 degree is just 1/360th of that. We'll get into minutes and seconds later. That's just a more precise way to get into degrees, okay? Now let's talk about a protractor for a minute. So a protractor can be used to measure the angle from the right or from the left. So if you measure an angle, let's say we put the vertex right here, see that 0 right there, and maybe we rotate 60 degrees, right? So that would be 60-degree angle. You can measure that on the protractor. You could also do it from the other side. See the 0-degree mark right there. Whoops. 0 degrees. Oh gosh, why does it keep doing that? Now you see the 0 right there. Let's say we rotate it, and now I'm using the outside one. Let's rotate it 100 degrees to right there. So there's 100 degrees angle, right? Going from the left-hand side there, rotating around. All right, let's move on and look at some examples here, just reading with a protractor. You can see we're using, for this one, it's the outside edge is 0 right there. And so we're reading the outside edge here. It looks like that ends up being 130 degrees. This one we're starting, the 0's on the outside on this protractor. We're rotating around. Looks like it ends up being 70 degrees there. You can draw a 110-degree angle with a protractor. Let's start it on the inside here, 0, and let's go around 110 to right there. You see the blue number, so there's 110 degrees. And you can also do that if you notice in the homework. Let me pull up a question here. what you do is you'll drag that protractor over onto the vertex, and then you want to drag the edge around so that you can measure it. And it looks like here we're going to measure this using the edge, the inner edge, 0, 10, around. It looks like it's 115 degrees or so. So I punch in 115 degrees on this one. Now here's some special angles. A 0 degree angle. And so you just got your initial side, and it doesn't rotate, right? It's 0 degrees. If you go all the way around, as we mentioned earlier, one full revolution is 360 degrees. If I only rotate a fourth of a revolution, that's 90 degrees, right? If I rotate halfway around, a half revolution, that would be 180 degrees. Any degree angle where I rotate less than 90 degrees is acute. And anything that's more than 90 but less than 180 would be obtuse. Complementary angles are two angles that add up to 90 degrees. See how 30 degrees and 60 degrees add up to 90 degrees? So when I hear complementary, I think corner. They're going to make up a corner. Like if I know this is 20 degrees and the other angle is complementary, then that's got to be 70 degrees because they make up 90 degrees together. Supplementary, think straight. So if this one's 50 degrees, then that would have to be 130 degrees because they add up to 180 degrees total. Supplementary straight angle, they add up to 180 degrees. So let's do some problems now with that information. Given the angle x, so we've got angle x is 20 degrees, and angle x and y are complementary. So here's angle y right there. They must add up to 90. So 20 degrees plus angle y are complementary. So it's got to be, angle y has got to be 70 degrees. Now if you have angle x being 20 degrees, and now it says they're supplementary, so they add up to 180 degrees because they're supplementary, then you could solve that. So angle y must obviously be 160 degrees. Now these two are showing you that they're supplementary, right? So you have this 4x minus 3, whatever that angle is, that many degrees, plus this 7x minus 4, this adds up, they're supplementary 180. Now let's combine like terms. I got 11x, negative 3 minus 4, I got minus 7 equals 180. Let me add 7 to both sides. So 11x equals 187. And then we divide by 11. So x ends up being 17. So what's the degree of the smaller angle? Well, the smaller one would be this 4x minus 3. And we know x is 17, right? X is 17. So 4 times 17 minus 3. Well, 4 times 17 is 68. Minus 3 is 65 degrees. So that's our answer. Because the larger one is that 7x minus 4. Well, 7 times 17 is 119 minus 415 degrees. That's the larger one. Again, they want the smaller. What's the smaller one? 65 degrees. So 65 degrees is that one. Now, if two angles are complementary, and one angle is 25 degrees more than the second angle, two angles are complementary, one angle is 25 degrees more, there's one angle, the second one is 25, I'm sorry, let me do it this way. One angle is 25 more than the second angle. So we'll call the second angle x here. So we have x plus 25 ends up being 90. Combine like terms. Divide by 2. Oops. So you got 32.5 degrees. And so it says one angle is 25 more than the second angle. We called the second angle x, right? The other one was x plus 25. So we just want this second angle being 32.5. We want the measure of the second angle. Now, how about this next one? The difference of two complementary angles is 74. Two complementary angles, so let's call them x and y. So the difference of these, the difference is 74. Now, we also know both of them added together, because they're complementary, is 90 degrees, right? Find the measure of both angles. Well, we could use elimination to do this. So x plus x is 2x, negative y plus y. I need one of those angles to cancel. And so I got 164 degrees divided by 2, and I've got 82 degrees. So that'll be my larger angle, because remember x plus y equals 90. They both add up to 90 degrees. So if the larger one's 82, then the smaller one would be 8. So smaller one, larger one. Last one here, two angles are supplementary. Two angles are supplementary. One angle is 20 degrees more than the second angle. Let me redo that then. One angle is 20 degrees more than the second angle. I'm calling the second angle x. Find the measure of the second angle. So we got x plus 20. These add up to 180. Subtract 20. So I got 2x equals 160 divided by 2, and I got 80 degrees. That would be our second angle. All right. Well, thanks so much for watching Points, Lines, and Angles. See you next time.